Okay, let's look at a practice test. Okay, and you will, again it says your this test can only be taken once, but this test can be saved and resumed later, just like it is for quizzes. Okay, you will see a number of multiple choice questions, and this goes back to the readings in the book, as well as what else you learn about physics in the Mechanical Universe videos, for example, or the Physics Plays tutorials, or my recordings. And there's a number of multiple choice questions. Most of the units will look really similar, with about 20, I guess 24 multiple choice questions, and then the last 6 or so, or in this case 7, are calculated formula, where you're giving some numbers and you have to figure out what the correct answer is. Usually, and notice that I usually give this one here, compute to two significant figures, but don't write the correct unit in this case this is meters per second. Down here omit the correct unit, J, capital J for joules. That's just because if you put it in, then it won't recognize it and will give you 0 points even if you have the same number. In a physical quantity, it is important to write the number in the unit. It's just that the way I set it up, I give away the unit to you. You just write in the correct number. By the way, if you compare what I show you here in this recording with the numbers that you actually get on your practice test, you will see that they are perhaps different. You might get, I get 58 meters per second here and 795 times there. Your numbers might look slightly different. Same thing here, 3.1 times as heavy and a speed of 6 kilometers per hour. Your numbers might look slightly different. That's the way I set up the problem. Okay, so that's actually basically it about practice tests and proctored exams. And of course, by the deadline, you have access to the practice tests all semester long from the very first day. So I don't see an excuse why practice test 1, practice test 2 should be taken after the deadline. Okay, let's go to labs. General guidelines for labs. Note that each of the 7 units contains 2 lab experiments, that a face-to-face class consists of 15 labs periods of 2.5 hours. Multiplied, that gives 37.5 hours per semester. And now if we divide and then plus a little bit extra time for pre-lab questions and lab reports, so around 40 to 45 hours in a regular semester, and here in this online class I expect that as well, that the experiments may not take that long, but if they do, well, compare it to a regular lab class where you have that many hours as well. So with 7 units, actually the 3 hours, the 3 hours on each lab experiment, that's a good amount of time, because there are 7 units with 2 experiments each, so that would come out to 42 hours. I don't think that you would actually go beyond those 3 hours, but expect that you might have to put in that much time. It contains reading through each lab sheet guidelines. I put a little footnote here that says that the lab sheets are written for my face-to-face labs at KPC. I didn't edit those because that would mean I would have to maintain 2 sets. So what you're using them for is as guidelines. And now it says, since you don't have the exact same equipment as I do, note that they're not containing the perfect instructions, but instead you need to use them as good guidelines. That also means that occasionally you need to improvise. Therefore, there are also some extra instructions contained in the lab assignments. That means I also have another one posted that is called the lab assignment, that then tells you what you actually have to hand in. So use my lab sheets as guidelines, but you do hand in what I call the lab assignment. Watch the instructors posted lab instructions, usually digital video on YouTube, and example calculations where I used recordings just like this recording here off my computer, also on YouTube. I did that for virtually every of the 14 experiments, so you actually see me, watch me do the experiment, and then I also show you example calculations. Answer each experiment's pre-lab questions, and there's a footnote for this one here, that they're geared towards you having understood the lab instructions correctly. Assemble and perform each experiment. And then this one is perhaps important, that once you have done the calculations, it's important that you have left the experimental setup intact so that you could go back and perhaps remeasure if you need to. Take a digital photo of yourself in each experiment, and of course I use it as evidence that you actually did it and not just went through the lab sheet and just filled in some numbers. Measure, analyze the data, compile the data and results, write a conclusion, and I get into detail in a little bit on that one. Post each experiment's lab assignment, submit the digital photos with the assignment, answer each experiment's post-lab questions, and the post-lab questions are usually geared towards that you compute with the equations that are given during the lab correctly. I also have another footnote here that says, is this reasonable to use a digital camera? And I believe it is. If you don't have one, well, ask a friend. Be creative about it, how you make photos of your lab experiments. Okay. Again, I will use Unit 3 as my example. So these are the lab sheets that are posted and that are used as guidelines. So when I click on Lab 7.2 Energy and Momentum, I come up with this one here, and you read through it, but you also have the lab video available to look at. I show you that in a moment. So it tells you how to do it, and in the lab video I tell you that as well. And then you fill in your measurements. So let me show you the lab video. I click on this one. Okay, actually I click on this one here, and you actually see me doing this lab experiment, trying to explain it as well as I can on what you have to do. Then you also click on the calculations. In this case I have 3 videos. Usually I might only have 1 video, and I show you how to do the calculations, and the equation that I plug in here is actually off the lab sheet guidelines, so you can follow that as I do that. Then what you have to hand in is the lab assignment itself. So you click on this one here, and you get the lab assignment that you actually have to hand in. There are 2 labs that you have to do: energy and momentum and simple machines. And notice that everything I put in this turquoise or light blue color, that's where you have to fill in something. Usually without units, I already put them in there for you. Occasionally you might come across something that doesn't have any units. Make sure that you attach them. And so yeah, this is what you have to fill in, and then you have to write a conclusion about it, which is usually about comparing results with a theoretical result. In this particular one, you measured the velocity of these foam darts in 2 different ways, and you compare the results from the 2 different ways. And in the conclusion there is always a footnote that says, tell me about what kind of measurement errors you could have had that influenced your results. And it says in a footnote also, don't just say human error, you have to specify what kind of error that is.